Video number 192, using a graphing calculator to solve an equation. Round to the nearest 100th, as they ask us to do. And actually what we may want to do ahead of time, here's a little sneak peek. Now first of all, we're going to throw this into our equation, into our graphing calculator. Here's how we're going to do this. We're going to put the left side in for one of the y equals equations, maybe y1. And then we're going to put the 220 in for maybe y2. I have it in as y3 and y4, but only because my calculator's got this little spot on here because I had it inside my bag and something rubbed against it, so it's semi-permanently damaged, but it's not a big deal. Now, you need to put the left side into one and the right side into something else. Now, what we're going to do is we're going to find where these two have an equal height. We're going to find where these two intersect with each other, and that will solve the equation. It's a pretty neat way of solving an equation. Now, what we may want to do here, it says round nearest 100th. Watch this. You may want to go to mode, right? And then we're going to go down to where it says float. That's how our calculator is being told to round. We're going to round to 2 decimal places. So we can put that in now. Then you can press, once you press enter on that, then press second mode so that you can quit out of it. Let's go to y equals. Bam, type in what you got. Press zoom standard. That'll be a standard window just so we could see what's going on. But actually that would have been, for some of you that are watching this are probably thinking, wait a minute, 220 is the height. Why don't we go up to at least 220 for the window, for a y, a maximum. So let's go up to 300 and see if that covers everything that we need. Alright. And as it turns out, we're not really able to see everything. Let's go a little bit further to the left. Because now again, this is not a quadratic. This is a third power, and obviously we're going to learn more of this as we go along. We're going to go further to the left, change the window, go to an x minimum of maybe -40. We're going to go by tens on the x scale. Press enter, and actually eventually press graph. Let's see what you got here. Yeah, just as I suspected, we have a couple more solutions as you go left. Actually, well, one more solution as you go left. Now, if you want, you can try to find out where this graph tops off. If you want to keep changing the x maximum, I think that's actually what I'm going to do, just so I can see what's going on. So I'm sorry, the y max. I'm going to go up to 1,000 and see if that covers it. And it actually does not. We would actually have to go taller. Why not? Why not? Let's go a little taller. Let's go up to 1,400. And since we've increased the y max so much, let's increase, or at least decrease, the y minimum. Let's go to -600 or something like that, just so we have a little bit more of a nicer, more scaled off graph. What we're looking for here to solve this equation here, guys, though, is definitely the 3 points of intersection. All right. Now, this is a good time to review something we're going to talk about later called the fundamental theorem of algebra. It talks about how if you have a third power, you're going to have at most 3 solutions. And you can tell here, obviously, that if this line would have been a little bit lower, if it would have been below this relative minimum, if this would have been like maybe -400 or something like that, down here at -200, well, we would only have the 1 point of intersection, as you can tell. All right, so what are we going to do? Well, we've looked at this in a couple of videos back. We're going to use the intersection. So we're going to press second calculate. We're going to go to the intersection, press enter. First curve, where are we? There it is. Yeah, that's the first curve, yes. Second curve, yes. Take a guess, yes. And we get -22.32. And wow, look at that. Imagine that. It's already rounded for us because we pressed mode and we're in good shape. Then we go over here. Same thing. Second calculate. Intersect. First curve. Okay, that's the first curve. Yes, that's the second curve, even though it's not curve. It's a straight line. And there you go. We have whatever that is. Oh, watch out, camera. Here we go. That's going to be -4.76, comma, 220. And by the way, guys, aren't all the y values going to be 220? So our x values are going to be approximately -4.76. Of course, there's that first one there. I think it was -22. Let's go back and summarize this the right way, right? First curve, second curve, take a guess. So it looks like as we get closer, let's see, -22.32. And And I guess we can put this in set notation. And then that third point of intersection, second, calculate, intersect, first curve. By the way, if you press up and down, it takes you from one curve to the next. If you press left and right, it takes you further along whichever curve or function and or line you are referring to. So we're going to scroll all the way over to that third spot, and there it is at positive 2.07. Kind of neat how the calculator will round it for you if you just press mode and you go over to float and you have it round to that particular amount of decimal positions. So, questions or concerns, please send me an email. Good times.